All right, we are back and the reaction has completed itself. So let me kind of show you what that looks like here. Try and see if I can zoom in. Not sure how well you can see that, but the level of the water in the burette is about where my finger is here. And so it is filled up the rest of the way with hydrogen gas. So I can move back out. There we go. So come all the way down here. All of this is filled up with hydrogen gas. So what we're going to do is we're going to measure what that hydrogen gas is, or that volume is, and then that's part of what you're going to use for your calculations. So one of the things that we have to do is we have to, as we said before, determine what is the pressure of the hydrogen in here, because the pressure is going to determine in part what the volume is, just like the temperature is. So we measured the atmospheric pressure out here, but that's not the pressure of the hydrogen in the tube. Because if you remember, there's two gases in that tube. There's hydrogen and water vapor. But that pressure that we measured out here, that 0.987 atm, is the pressure of the system. And one of the things that we can do to ensure that the pressure inside the tube is the same as the pressure outside is to equilibrate it here a little bit. So I'm going to just kind of move the tube not upside down, but up and down in my beaker here to make sure that the pressure inside the tube is equilibrated to the pressure outside the tube, which we measured. I didn't really show you, but in my stopper at the end of the burette, there was a hole that allowed all this water to come out that was in the tube as the pressure built up. So what forced the water out? Well, the pressure of the gas. So as this builds up, it allows the water to come out. But it allows the pressure inside the tube to be equilibrated and equal with the pressure outside the tube. Okay? So if I read my volume now, so I'm going to get down here and read what I have left in my tube. Looks like I have a volume of about 2. Looks like it's about 2.6. 2.60. Okay, so let's call it that. I think it's, should have my other glasses on, be a little bit easier too, but I can use the water to help me out because water refracts and bends the light in such a way to magnifies things, right? So I've got about 2.6. We'll say 2.60. I think that's going to be close enough for us. So that is how much water remains in my tube. So how much gas is there? Well, I started at 50. But if you remember, I also had this a little bit up here that I had to measure. So that amount was 0.7. So I really started with 50.7 milliliters of water in my tube, and I'm left with 2.6. So how much gas do I have in there? Is the difference between those two. So if I subtract those two, it gives me a volume of about 48.1 milliliters of hydrogen gas. 48.1 milliliters of hydrogen gas. Okay? So I'm going to need that information in my data table. So again, here's the data that we took. This is the volume of the hydrogen gas that we measured in our lab. This was the pressure that we were at, 0.987 atm. This is the temperature that we were at, right? This was that extra space above that filled with air, so I added that into my 50 to begin with. And this is the mass that I have. So this is going to be an important number that we're going to need. The temperature is going to be a number we're going to need. The pressure is going to be a number that we're going to need. and the volume of hydrogen gas is going to be a number that we're going to need. So from the volume, temperature, pressure, and this mass, we can calculate the molar volume of that hydrogen gas. And that's what you're going to need to be able to do in the next part of this lesson, is to do those calculations. Okay? So I'm just going to kind of show you what you're going to do next, and then I will cut the video off, and you'll be doing calculations. So on this page here, there was a data table, so you can make a data table similar to this in your lab report. Again, you're going to do an electronic lab report like what you normally do, title, purpose, all that kind of stuff. Use this document as your guide, right? So you've got a data table there, and then the calculations and analysis section will be the calculations that you'll need to do, which will eventually get you to the point of identifying the molar volume of hydrogen. Okay, so these are going to be things that you need to do on your own at this point. Okay, what we will do is tomorrow I'll come back and do a live Zoom conference. And if you have questions about anything here, you need to be a part of that live conference. If you think you've got it all, then that'd be great. Okay, I'll just review a few things with you. So it says calculate the number of moles of hydrogen gas. You should be able to find moles. All right, we measured the mass of the magnesium. Okay, and according to your balanced equation, all right, the magnesium and the hydrogen gas have a 1-to-1 mole ratio. So if you know the moles of magnesium, which we do because you've got the mass of magnesium we use, you should find the moles of hydrogen. So you should be able to do that. Second one says use table 1 of the background information, find the vapor pressure of the hydrogen or the vapor pressure of water at the temperature in the experiment, and then use partial pressure of hydrogen gas to find that. That's using Dalton's law. So that goes back to this table in the handout, where you're going to use the temperature that we measured the experiment at and find the vapor pressure of water at that temperature. Because what we find is that water will evaporate into vapor more at higher temperatures, right? When it's hotter out, water evaporates more. When it's colder out, water doesn't evaporate. That's why in wintertime, the air is usually kind of dry, right? In the summertime, it's more moist, because when the temperature rises, you can have more water vaporize into the air. So you'll use that, and then Dalton's law. So think back to what we did on Friday. If you know the total pressure of our system, and you now know the vapor pressure of the water portion, you should be able to find the pressure of the hydrogen portion. Think back to Dalton's law. All right. Then question number 3 says use the combined gas law, PV over T, right? And take your amount of hydrogen that we measured today and determine what would that volume be at STP. Because today we had a certain volume at a temperature of 18.7 degrees, right? And a pressure of 0.987. Those are not standard conditions. So you're going to use the combined gas law to help you find out what would be the volume of this hydrogen if we would have done it at STP conditions, standard temperature and pressure. So P1, V1 over T1 equals P2, V2 over T2. Okay, that's the equation you use for number 3. And then number 4 tells you exactly what you're going to do. You're going to divide the volume of hydrogen at STP, which is what you got in question 3, by the number of moles of hydrogen that you got in question 1. All right, and that's going to give you a value that represents number of liters volume per mole, and that's what we call the molar volume. Okay, the rest of the calculations here, number 5 is percent error calculation, and then the other 6 questions aren't calculations, they're just questions about errors and things that might have affected our data here. Number 9 at the bottom, you can cross out, we are not doing the optional one. So you'll do 1 through 8, okay? And then you'll need to write a conclusion, obviously, for your lab reports, all right? So in terms of the rest of the week, today is Monday, we've done the lab today. Tuesday, You should have worked on the calculations before the Zoom conference on Tuesday. I think it'll probably be at 11 o'clock because that's when science is supposed to do our conference meetings, right, from 11 to 12. So I'll be online then if you need help with the calculations. If you're figuring it all out, you don't need to come online. Just keep working. And then Wednesday and Thursday is designed to give you time to work on your lab report, your title, purpose, background information, list of materials, data table, procedure, the whole works. Okay? If you want to do that all on Tuesday and be done for the rest of the week, then that's great. All right? But you do need to have the lab report done by the end of the day on Thursday. That way you won't have to worry about anything over the Easter weekend, and then we would be back the following week on Tuesday, so we don't have official school on Monday then. Okay? All right, so hopefully you enjoyed watching the experiment a little bit. You got your data, work on your calculations, and we might see you tomorrow on the video conference on Zoom. All right, have a great day. Hope the rest of your classes are going well. I know this is starting to get sometimes a little tedious now with all of our online learning, or more appropriately, it's called remote learning now, as we found out. But hopefully you're hanging with it. And again, if you've got some issues, you need to communicate. If it's in my class, obviously with me. If you've got issues in other class, you need to communicate with those teachers too, and we're willing to help you out. All right, have a great day.